Hey YouTube, welcome back. This is the first devlog in my series about me building my very own game engine and game from scratch in WebGPU. Just a refresher, I'm working on a game where you can spawn thousands of units and code them and move them around and have them fight against each other, and very much in the future have it all be multiplayer. So here I have a little void system with this circle just pushing them around. All of this is done directly on the GPU, so all these little voids colliding with each other and this collision logic all happening on the GPU, which usually was not possible or was very tough to do because of WebGL. But now that we have WebGPU, a great new graphics framework for the web, we can do stuff like this. So that's why I was very excited to get started on this project. You can even click and drag and spawn it, quite satisfying, and you can mess with them here. So that's one part of the engine done, and the second part was being able to actually interact with these units through your own code that you write. So I'm using a library called CodeMirror to create this code field here, and I can actually directly go ahead and interact with the units in here. So for example, I can get game.units for each unit, and I can be like unit.move to say like 50, and you can see. And now, for example, I want them to go to -5, and then for example I want them to line up horizontally. I'll give that the index there, and then I'll maybe multiply this by 0.5, and then you'll see they'll start to line up sequentially based on their index. So this is already a very cool visual way to play with loops and positioning and just learn the very fundamentals of programming. But really I want this to be a very fun, real-time, hands-on kind of combat game. So that's my goal, and this is the very first steps to making that a reality. So let me just dive a little bit into the code and show you how and what I've done so far. So I'm using React as the base project. So in app.ts, I create a new engine. So the engine is a class that I've made, and the engine sits at the top and goes down into renderer and scene. So the renderer is responsible to talk to WebGPU and actually render quads and the shaders and the materials and all that kind of stuff. And the scene gives stuff to the renderer and says, here, draw this with these materials. So renderer is really boilerplate kind of WebGPU stuff. In the scene side, I've copied exactly how Unity does all of their scene management. So at the top you have the scene, and the scene has a bunch of useful stuff like an input system, the active camera, the renderer that it's on, and also all the game objects that are within it. So scene has game objects, and game objects can have an array of components. Now the component class is very simple. It has all these lifecycle hooks, which the scene calls. So now if I wanted to create a new piece of functionality, I would create a new component and attach it. Also, the game object has a bunch of cool stuff, like for example I can say get component of type similar to Unity. So I can say this.gameObject.get component camera, and then I can use the stuff within that. So in practice, here is the void scene, and for example here when I'm creating the collider, create a new game object, add the collider component, and then I can construct a material with the texture, and then I can add the quad mesh component, and I can set its color and set collider.transform.position to wherever I need it. So it's a very nice workflow with this component kind of architecture. Now, the final bit of abstraction that I really wanted to do was for the compute shader stuff, because 90% of my game logic is going to be in the compute shader. So this is another reason why I really wanted to create my own engine, because unlike traditional games, most of my logic is going to be on WGSL files. So here you'll notice for example, this is the compute shader class that's doing my avoidance and movement of my units. You'll notice I'm not declaring any structs or any bindings as you'd usually see in a WGSL file, because I'm dynamically generating all of that. So this is the final abstraction layer. So what I can do, if I go to Boyd compute, this is where in TypeScript, I can declare all of the data that's going to be in a compute shader and what that transformation between CPU side and GPU side looks like. So I can declare a class Boyd data, for example. So I'll bring this here. So I can declare a Boyd data class, and I can give it mark different variables, target position, avoidance vector, has target, with a shader property and its corresponding shader type. Now you can see here Boyd data. So this Boyd's object is going to be declared in this Boyd compute. You can see Boyd's is an array of Boyd data. So here there's another decorator called shader buffer, so I can create a compute, extends compute, and I can declare all the variables that I want to have in my compute shader and mark it with shader buffer, and I can give it some properties. And if this Boyd data, whatever type this is, has any shader properties, it knows exactly how to take the CPU data, so this vec4, and convert it into GPU accessible data. And even better, now if I want to query the GPU, say give me now all the updated Boyds that you've computed, I can just say give it back to me in this format. So now I can write data with TypeScript, and I can read data back into TypeScript. And this is super handy, and it allows me to add new variables and new classes very quickly. So now the colliders have a variable here, for example shape, determining what kind of shape it is. Now where is this coming from? This is just a component, but I can mark some stuff in this game component with shader property. So now I can pass game components directly into the GPU. Higher level game logic never needs to know about it. So it's absolutely easy to write new compute logic. And that brings me to the end of this video. I'm trying to keep these videos as short and sweet as possible so I can release as many of them as possible. I work a 9 to 5, so I'm trying to do the game in the morning and in the evenings. I really want to get an MVP out by the end of this month or middle of February, and I'd love to build a little community and share it around. I'm also going to get into the designing and the visual aspects of the game as well in the next devlog, so I'd love your feedback and all of your support. Thank you so much for tuning in, and I'll see you guys all next time.